Hello everybody, I hope you're doing well. We're going to be looking at another Cayley 2004 question in this video. It's going to be question number 13. Hopefully you've given that a bit of a shot. Tried it out for yourself. In the diagram, a smaller square lies inside a larger square. Okay, so we're told these are squares, but they're not connecting in any way. Usually when I see these sorts of smaller square inside a larger square, they're tilted and they're connected and we get right angle triangles. We don't have anything like that this time. The perimeter of the smaller square is 72 centimeters. Well, if I know the perimeter of a square, I can work out the side length of that square. Good to know. Good to start thinking about this. What information am I given, and how can I turn that into other information that I might need? The shaded area is 160 centimeters squared. The perimeter of the larger square in centimeters is, okay. So we're given some areas, we're asked for some perimeters. Well, these guys are squares, and really to know anything about a square, we should know its side length. So I'm going to not only name these side lengths, but I'm also going to I can work out the side length of that smaller square. Hopefully from there, I'll get the area, add on the shaded area, get the area of the big one, get its side length, and then get the perimeter. So 5 or 6 steps in there, but we've got a plan of attack before we even put pen to paper. Good idea. It's always a good idea to practice. What am I about to do? Don't just start word vomiting unless you got no idea where to go. Or I guess not word vomiting, but number vomiting. You don't want to just be doing a whole bunch of stuff. You want to sort of get a plan. Okay? If you don't have one, then yeah, just start figuring out any information that you can. And hopefully eventually you'll sort of see a plan fitting in. So I'm going to say capital A and little a. These are my side lengths. Okay? So I know the perimeter of my square is going to be 4 copies of A. But we're told that that's 72 centimeters. If I divide both sides by 4, I get A is 18 centimeters. Okay. So that means the area of the small square going to be 18 centimeters squared, all squared by the way, so that's 324 centimeters squared. So the area of the large square, not only is that equal to a squared, the side length that I have specified, but it's also the small square plus the shaded area. So a squared is going to be 324 centimeters squared, plus we were told 160. So that'll be 484 centimeters squared. And maybe you recognize that 484 is 22 squared, or maybe you need to grab your calculator, and that's okay. We can certainly use our calculators on this competition. Make sure you know how it works. But you never feel shame just because I can do something in my head and you can't. Keep doing these contests, eventually you will. I try and get people to know their squares up to 20 squared, 30 squared, that sort of thing. So if you just knew up to 20 squared, it'd be fine in most circumstances. You wouldn't know this one off the top of your head. But certainly if you knew up to sort of 30 or 31 squared, these are great ones because 31 squared is 961. It's just below 1,000. So you know all your squares up to all the 3-digit numbers. You would know that this is 22 squared, but calculators are allowed, so don't worry about it. I think all Waterloo contests, calculators are allowed. Just sometimes it's not really helpful. In this case, it might be. Okay. So A is going to have to be 22 centimeters. Okay. We're not done yet because we need the perimeter. Well, the perimeter is going to be 4 copies of A. 1A, 2A, 3 A's, and the 4th A up top. So 4 times 22, hopefully you guys can do that one in your head. We're going to have 88 centimeters. I think that was B. Yes, it was B. Good memory. Okay, and that was question 13. Yes, it was. Good memory. We'll be taking a look at question number 14 in the next video, and I hope to see you guys there.